In 1977, the National Aeronautics and Space Administration, NASA, launched two robotic explorers, Voyager 1 and Voyager 2, into space on an ambitious mission unlike any before. These twin spacecraft were engineered with the goal of exploring the farthest reaches of our solar system and continuing onward into interstellar space. Designed to push the boundaries of human knowledge, they were equipped with the most advanced technology available at the time. Their mission was to investigate the outer planets, Jupiter, Saturn, Uranus, and Neptune, and to send back data that would dramatically reshape our understanding of the solar system. Both Voyagers were fitted with sophisticated instruments that allowed them to capture high-resolution images and analyze atmospheric conditions, magnetic fields, and particle environments of the planets they encountered. As they embarked on their unprecedented journey, the data they collected offered breathtaking insights. Voyager 1 and 2 provided humanity with our first detailed views of Jupiter's massive swirling storms and Saturn's magnificent ring system. The photographs and information they transmitted brought the distant corners of our solar neighborhood into clearer focus, transforming them from specks of light into dynamic and diverse worlds. One of the most symbolic elements of the Voyager missions was the inclusion of the golden record on each spacecraft, a 12-inch gold-plated phonograph record encased in an aluminum jacket. This interstellar message was crafted with care to represent the diversity and creativity of life on Earth. It contained 115 images, natural sounds of our planet, greetings spoken in 55 languages, and a medley of musical pieces from different cultures and eras. The golden record was not just a scientific artifact, it was a hopeful message to any extraterrestrial intelligence that might one day encounter the spacecraft, expressing a desire for connection and understanding. Voyager 2's first major planetary encounter came in 1981, when it reached Saturn. Although Voyager 1 had already passed by the ringed planet, Voyager 2 was able to delve even deeper, aided by knowledge gained from its predecessor. It revealed astonishing complexities within Saturn's ring system, structures that included kinks, braids, and waves, challenging the prior assumption that the rings were flat and uniform. These discoveries suggested a dynamic environment shaped by gravitational interactions with the planet's many moons. Several years later, Voyager 2 reached Uranus, a planet shrouded in mystery and marked by an extraordinary axial tilt of about 98 degrees, which causes it to roll on its side as it orbits the Sun. Voyager 2 was the first, and remains the only, spacecraft to visit this distant ice giant. It photographed Uranus's icy, pale blue atmosphere and revealed 2 previously unknown rings and 11 new moons. The spacecraft also measured Uranus's frigid temperatures, which plunged to 353 degrees, 213 degrees, and observed a massive plasmoid, or bubble of plasma, that helped scientists better understand the planet's unusual magnetic field. Perhaps the most iconic image captured by the Voyager missions was not of a distant planet, but of Earth itself. In 1990, from a distance of more than 4 billion miles, Voyager 1 looked back toward home and snapped the now famous pale blue dot photograph. Earth appeared as a tiny speck, just 0.12 pixels wide, suspended in a beam of sunlight against the vast backdrop of space. This haunting image, which inspired astronomer Carl Sagan's reflections on the fragility and unity of our world, forever changed how we perceive our place in the universe. As the years passed, both Voyager spacecraft continued their journeys, traveling farther than any human-made object had ever gone. In 2012, Voyager 1 crossed the boundary of the heliosphere, the bubble-like region of space influenced by the solar wind, and officially entered interstellar space. Voyager 2 followed in 2018. Even in this largely uncharted realm, the spacecraft remained active, continuing to collect and transmit scientific data. One of the most significant recent discoveries came from Voyager 2's plasma wave instrument, which detected a steady hum from interstellar plasma. This marked the first continuous measurement of the density of plasma between stars, offering groundbreaking insight into the environment that exists beyond our solar system. Despite the incredible distance, now over 14 billion miles from Earth, Voyager 2 continues to send data back to mission control. Its longevity is a remarkable feat, especially considering it was originally expected to operate for just 5 years. More than 4 decades later, it still contributes to scientific discovery. To conserve power, engineers have skillfully turned off non-essential systems while prioritizing critical instruments. Today, Voyager 2 runs on less energy than a household light bulb, yet its contributions to science remain immense. In 1989, Voyager 2 made its final planetary flyby at Neptune, making it the first and only spacecraft to visit this deep blue ice giant. It sent back images of Neptune's thick atmosphere, punctuated by massive dark storms and the fastest wind speeds recorded in the solar system, up to 1,200 miles per hour. Voyager 2 also investigated Triton, Neptune's largest moon, discovering active geysers that expelled icy material into space, as well as hints of a subsurface ocean beneath the moon's frozen crust. Additionally, it revealed that Neptune's magnetic field was significantly tilted and offset from the planet's center, presenting a puzzle that scientists are still working to solve. Voyager 2's mission has become a symbol of human ingenuity, resilience, and the desire to explore the unknown. Even as its power supply dwindles, the spacecraft continues to operate thanks to the careful management of its limited resources. Each year brings new challenges, requiring the mission team to make difficult decisions about which instruments to keep running. Nevertheless, Voyager 2 endures, both as a scientific probe and as an ambassador of Earth. Beyond its scientific mission, Voyager 2 serves a deeper purpose. The golden record it carries is a timeless message of peace and curiosity, capturing the essence of life on our small planet. From the sound of a mother's heartbeat to greetings from around the globe, this record transcends time and culture, offering a glimpse into the human experience to any beings who may one day come across it in the distant cosmos. The spacecraft's legacy will outlast its transmission signals. Long after its systems shut down, Voyager 2 will continue its silent voyage through the galaxy, a drifting emissary of our civilization. The discoveries it made have influenced countless future missions, from spacecraft probing the icy moons of Jupiter and Saturn, in search of life, to telescopes scanning for habitable planets beyond our solar system. The final images captured by the Voyagers, including the faint glimmers of distant stars and the frozen beauty of the outer planets, serve as a lasting reminder of the power of exploration. These photographs reflect how far we have come as a species and hint at the immense wonders still waiting to be discovered. Voyager 2 has not only charted a course through the stars, it has helped humanity find its place among them. Ultimately, the Voyager missions stand as enduring testaments to the power of curiosity and the human spirit. Though Voyager 2 will one day fall silent, its journey has already changed history. It continues to whisper across the cosmos, echoing our dreams, our questions, and our drive to uncover the mysteries that lie beyond the stars.